Okay, so some notes for writing inequalities. So first we need to identify the inequality symbol by looking at the circle and the direction of the arrow. So if I was looking at a number line here, I would need to pay attention to the circle to see if it is open or closed. So open means that it's not filled in, and closed means the circle is filled in. So I need to pay attention to my circle as well as the direction of my arrow. So if my arrow is pointing to the right, then that means I use the greater than symbol. If it's pointing to the left, that means I use the less than symbol. And then my circle would also tell me whether it needs the or equal to part of the symbol. So if my circle is open, that means that that specific point would not be included in a possible solution. So it would just be greater than. Whereas if the circle is closed, which means filled in, then that means that specific point is also a solution that would make the inequality true. So for that, I would need the or equal to. So when we write our inequality, the variable always goes on the left side. And then we write our inequality, and then we can check it by picking a point or number along the arrow and substituting it into the inequality. So to identify the symbols, so I need to look at my circle, and I notice that my circle is filled in, and my arrow is pointing to the right, which tells me that it is greater than, and the circle being filled in tells me that it's greater than or equal to. Okay, the next one. So now my arrow is pointing to the left, which tells me I have the less than symbol. And this circle is open, so I just need to leave it as less than. For this symbol, it's pointing to the left, which tells me less than. But now my circle's filled in, which tells me it's actually less than or equal to. And then the next one, it's pointing to the right, which tells me greater than. And my circle is open, so my symbol stays as greater than. Now, writing inequalities from descriptions. So you want to identify keywords, which let you know which inequality symbol that you'll use. And then identify what operations you'll be using. So if there are keywords that let you know that you're going to be adding, subtracting, multiplying, dividing, and so on, you need to identify that. Then you need to define your variable. So figure out what your variable is and what it's representing. And then you can write your inequality. So if we have the sum of a number and 3 is no more than 8. So first I need to identify keywords that would tell me what symbol I'll be using. So the keywords for that would be no more than. So if it's no more than something, then I know it has to be less than or equal to. And then define my operations. Well, I have a word that says sum here, which tells me that I'll be using addition. I need to figure out what my variable is. And it says the sum of a number. So I don't know what this number is. So I know that's my variable. So the sum of a number and 3 is no more than 8. So now I can write my inequality. So I know that y plus 3 is not more than 8. But that it doesn't say that it can't be 8. I just know that it's not more than 8. So it'd be less than or equal to 8. Okay, then we have the difference of a number and 4 is at least 10. So I need to find my keywords for my symbol, and at least tells me that it is at least 10. So that means it can be more or equal to 10. So greater than or equal to. Difference means subtraction. So I know I'm going to be subtracting. And then I have a number, which is my variable, and 4. So I'm finding the difference of a number and 4. So y minus 4 is at least, which is greater than or equal to 10. Okay, the maximum number of students who can fit on one bus is 45. So my keyword here for my symbol would be maximum. So that means whatever number I'm finding, it can't be any more than 45. So that means it has to be less than. But it gives me my maximum. So that means that's the highest possible number that it could be. So it could be that number. So it's less than or equal to. So my number of students, which I do not know, so that would be my variable. And I don't see any things that would tell me an operation. So now I can just write my inequality. So my number of students that can fit on one bus is at maximum 45. So that means the number of students on my bus has to be less than or equal to 45 in order for them to all fit. Okay, she wants to sell more than 10 boxes of cookies. So more than tells me that I'm going to use the greater than symbol. It doesn't say that she wants to sell 10 boxes or more. It says she wants to sell more than 10 boxes. So I do not need an or equal to in my symbol. And then my variable is going to be talking about the boxes of cookies that she sells. Again, I don't have any words that would indicate an operation, so I can just write my inequality. So the boxes of cookies that she wants to sell is greater than 10. Okay, now using the number line to write inequalities. So again, I want to look at my circle. And I see that my circle is at -5. I'm just going to use x as my variable. And then I have to pay attention to the direction of the arrow. So it's pointing to the right, which tells me greater than. And my circle is open. Number 2. Again, it's pointing to the right, which tells me greater than. My circle is closed, which tells me or equal to. My circle is at +1. So I know x is greater than or equal to 1. Number 3, my arrow is pointing to the left, so that would be less than. And my circle is closed, which means less than or equal to. And my circle is at 3. So x must be less than or equal to 3. Number 4, I'm pointing to the right again. So greater than, my circle's open. So that tells me that x must be greater than 4. Number 5, I'm pointing to the left, which is less than. My circle is closed, which means or equal to. And my circle is located at 0. So x is less than or equal to 0. Number 6, pointing to the left. My circle is open, so x is less than -4. So if the circle is filled in, which is called closed, so if the circle is closed, you need the or equal to in your symbol. And then the direction of the arrow will tell you if it's greater than or less than. Then to solve inequalities, so we follow the same steps as we did for equations, except now we have an inequality symbol. So equations have one possible answer, whereas inequalities could have more than one answer for that equation. So again, we want to follow the same steps, which is to use the order of operations, but work backwards, and then use the inverse of those operations. So I have negative 3 times x plus 5. Following my order of operations, I'd want to do multiplication first, then my addition, but because I'm working backwards, I want to worry about the addition first, but I need to use inverse. So the inverse of adding 5 would be subtracting 5. So negative 3 times x is greater than or equal to 20 minus 5, which is 15. So now I have negative 3 times a number. So I want to use the inverse, which would be division. So divide both sides by negative 3. So x is greater than or equal to 15 divided by negative 3, which is negative 5. But I always want to check my inequality. So to check it, it's best to check with a number above and the number below your solution. So I want to check negative 4 and negative 6. So let's check negative 4. So it says x is greater than or equal to negative 5. So negative 4 would be greater than. So to check it, I just plug in that number. So negative 3 times negative 4 plus 5 is greater than or equal to 20. So negative 3 times negative 4 would be 12 plus 5. 12 plus 5 is 17. And is 17 greater than or equal to 20? No. So now I need to check negative 6. So I have negative 3 times negative 6 plus 5 is greater than or equal to 20. Negative 3 times negative 6 would be positive 18. Plus 5 would be 23. And is 23 greater than or equal to 20? Yes. But is negative 6 greater than or equal to negative 5? No. Negative 6 is less than or equal to negative 5. So my symbol needs to be switched. So my solution is actually x is less than or equal to negative 5. So when you multiply or divide both sides by a negative, your symbol will switch. So if you multiply or divide both sides by a negative, you must flip your sign. And your symbol. Okay, so moving on to number 2. I'm going to get this out of our way. So we have 8 times x plus 4 is greater than 8. So again, there were 2 different ways that we could solve problems like this. We can use the distributive property, or we can just divide to get rid of the 8. So one method would be to use distributive. So 8 times x would be 8 times x. 8 times 4 would be 32. So that gives me 8 times x plus 32 is greater than 8. Or I also could have just divided. So when I had 8 times x plus 4 is greater than 8, I could divide both sides by 8, which would give me x plus 4 is greater than 1. Then I would subtract 4 from both sides. So x is greater than 1 minus 4, which is negative 3. And then going back to this distributive method. So if you use distributive, now I need to subtract from both sides first. So subtract 32 from each side. And that gives you 8 times x is greater than 8 minus 32, which is negative 24. Now I can divide both sides by 8. And that gives me x is greater than negative 24 divided by 8, which is negative 3. So you see both methods gave you the same answer. And again, like we did above, you could just plug in a number below and a number greater than negative 3 to test that to make sure you got the correct answer. But because I did not divide or multiply by a negative, I know my symbol needs to stay facing the same direction. So x is greater than negative 3 would be correct. On number 3, again, you can use distributive or divide out. For this one, I'm just going to go ahead and use division. So I'm going to divide both sides by 5. So that leaves me with negative 2 times x minus 8 is less than 20 divided by 5, which is 4. Now I can add 8 to both sides. So negative 2 times x is less than 4 plus 8, which is 12. Now I want to divide both sides by negative 2. So x, and then 12 divided by negative 2 is negative 6. But remember, I divided by a negative, so my symbol needs to flip. So since it was less than, now I need it to be greater than. So x is greater than negative 6. Okay, on these problems, you're determining whether or not the given ordered pair is a solution to the inequality. So an ordered pair is just an x and y coordinate. So it's a point on a coordinate plane. So the first number is always your x coordinate. And the second one is your y coordinate. So if I have x plus y is less than negative 4, I just substitute those points in. So x is 0, y is negative 5. So 0 plus negative 5 is negative 5. And is negative 5 less than negative 4? Yes. So that means my ordered pair 0, negative 5 is a solution. Okay, number 8. I have 2.8 times x, which is 0, plus 4.1 times y, which is also 0, is greater than or equal to 1. So I have 2.8 times 0, which is 0, 4.1 times 0, which is also 0, and then 0 plus 0 is 0. And is 0 greater than or equal to 1? No. So this ordered pair is not a solution. Okay, writing and solving inequalities. So we have number 1, Benny had $35 to spend at the store. He paid $10 for a DVD, and then he bought some packs of gum for $2 each. What is the maximum number of packs of gum that he could purchase? So I need to decide what my variable is. And this says to let P be our variable, and it would represent the packs of gum. Okay, and now I need to figure out my inequality. So I know Benny is paying $10 for a DVD, and then his packs of gum are $2 each, but I don't know how many packs of gum he's purchasing. But I know they each cost $2. So each pack of gum costs $2, so 2 times P, plus the $10 for the DVD. And I know he only has $35 to spend, so my total has to be less than or equal to 35. So I have 2 times P plus 10 is less than or equal to 35. So now I can solve it. So I subtract 10 from both sides. 2 times P is less than or equal to 25. Divide both sides by 2. So P is less than or equal to 12.5. But the problem is asking me what the maximum number of packs of gum he could purchase. Well, since I can't purchase half a pack of gum at a store, then I know that Benny can buy, the maximum number that he can buy is 12 packs of gum. So he can purchase 12 or fewer packs of gum. Number 2, Nikki can spend $50 at the mall. She finds a pair of shoes that cost twice as much as a shirt. So what is the most that the shirt can cost? So my shoes cost twice as much as my shirt. I don't know how much my shirt costs, so I know that would be my variable. So C represents the cost of a shirt. So now I need to determine my inequality. So Nikki's purchasing a pair of shoes and a shirt. So my shirt cost C dollars, and my shoes cost twice as much as my shirt. So that means 2 times that amount. So 2 times C. So my inequality is 2C plus C is less than or equal to $50. So before I can solve this inequality, I need to notice that I have 2 sets of the same variable. So I have 2 C's and then I have 1 C. These are considered like terms because they are the same variable. Therefore, I can combine those to simplify this problem. So if I have 2 C's and then I add another C, I have a total of 3 C's. So 3 times C is less than or equal to 50. So now I want to divide both sides by 3. So that tells me my cost of my shirt must be less than or equal to 16.6 repeating. But I can't have repeating decimals with money. So the most that this shirt can cost, and that should say a shirt. So the most that a shirt can cost would be $16.66. So because this says less than or equal to, I know that it can't be any more than $16.66. So I couldn't round to 16.67 because is that less than or equal to 16.6 repeating? No. So $16.66 would be the most that shirt could cost. Okay, number 3, Hannah has $400 to spend on vacation. She is going to be gone for 3 days and wants to know what is the most that she can spend each day. So M could represent the most spent on each day. So the money spent each day. So the money spent each day. And I know she's going to be gone for 3 days. So 3 times M must be less than or equal to 400. Because she can't spend more than $400. She can spend $400, but not more. So then I just solve it. So 3 times m is less than or equal to 400. So I would divide both sides by 3. So that would give me $133.3 repeating. So the most I can spend each day would be $133.33. Okay, and number 4, Tavares is saving for a $350 cell phone. He already has $60 and he plans to save an additional $20 per week. So how many weeks will Tavares have to save before he can buy the cell phone? So I know he already has 60, plus he's going to save 20 each week. And I'm trying to figure out how many weeks. So the W would represent the number of weeks. So I don't know how many weeks, but I know each week he is saving $20. So $20 each week, plus the 60 that he already has saved. And I know he needs to save $350 for the cell phone. So to purchase the cell phone, could I save an amount that's less than $350? No, I have to have at least $350. So the amount that I save has to be greater than or equal to $350. So now we can solve it. So 20 times W plus 60 is greater than or equal to 350. So I can subtract 60 from each side. So that gives me 20 times W is greater than or equal to $290. Then I can divide both sides by 20. So that gives me W is greater than or equal to 290 divided by 20, which tells me that the number of weeks that Tavares needs to save is greater than or equal to 14 and a half weeks. So he needs to save for at least 14 and a half weeks. And depending on the problem, if he couldn't save for half of a week, then he could save for 15 weeks. So I could say at least 14 and a half weeks.